Hello everyone, I hope you all are doing well. Let us start one question from classical mechanics and that is from Lagrangian. Okay, a disk of mass capital M and its radius r slides without friction on a horizontal surface. Another disk of small m radius r pinned through its center to a point. Okay, so a point of the center of the first disk by a distance b so that it can rotate without friction on the first disk. Okay, as you can see in the figure that a bigger disk is sliding and its mass is capital M and its radius is capital R, and a smaller disk is of mass small m and its radius is small r, and that is pinned at a distance p from the bigger one, and that is rotating frictionlessly. Okay, see how its view. This is bigger one and a smaller one at a distance b, that is fixed here, and both are rotating. Okay, and the angle of rotation for the bigger one is theta and the smaller one is phi, angle of rotation. Okay, about its axis and perpendicular to the plane of rotation. Okay, then we have to find out the equation of motion for the system. First we have find out the position coordinate. Okay, position coordinate first is for bigger one its position coordinate is xy, as you can see, and for the smaller one the position coordinate is quite shifted from x and y, so that is x dash is x plus c. If I draw a perpendicular distance, then by Pythagoras you can see that this distance is b cos theta and this distance is b sin theta, and its center coordinate is xy, so the shifted coordinate will be x plus b cos theta and y dash will be x y plus b sin theta. Okay, from this you can find out x x prime dot is equal to x dot plus b minus sin theta dot, and then y dot prime will be y dot plus b theta dot cos theta. Okay, and then the kinetic energy of the whole system will be half capital M x dot square plus y dot square plus half small m x prime dot square plus y prime dot square. So the kinetic energy half, and see that the total kinetic energy is the translational kinetic energy, and here also rotation is happening, so rotational kinetic energy we have to take consideration. So half I omega square, that omega 1 square plus half I omega 2 square. Okay, here the omega 1 is the rotational coordinate we have taken for bigger one is theta, so that will be theta dot omega, and omega 2 will be phi dot. Okay, and here also the disk as you know the moment of inertia of the disk is half m r square, and that is of half small m r square. So see the thing, x dot square plus y dot square plus half small m If you do the squares, then that will be x dot square plus b square theta dot square sin square theta plus y dot square plus 2x dot minus b theta dot sin theta plus y dot square plus b square theta dot square cos square theta plus 2b y dot theta dot sin theta, sorry, cos theta. Do simplify by your own. Okay, then half into uh, put the value of 5 and write the things. Half capital M r square theta dot square plus half into half small m r square and it's phi dot square. If you simplify this, then terms will be half capital M x dot square plus y dot square. Take common x dot square plus y dot square, that will be then capital M plus small m plus half b square theta dot square sin square theta minus 2 x dot b dot sin theta plus b square theta dot square cos square theta plus sin square theta will be b square plus theta dot square. Okay, and then plus 2b y dot theta dot cos theta. Okay, plus 1 by 4 m r square phi dot square, sorry, theta dot square m r square theta dot square plus 1 by 4 small m r square phi dot square. Okay, that is the kinetic energy. As you know, the potential is 0 here because there is rotation happening, so the potential energy is 0, so that will be also the Lagrangian. As you know, the Lagrangian is kinetic energy minus potential energy. Okay, then do you know the equation of motion of Lagrangian? As I hope you all know. Okay, that equation of motion is del L by del Q dot my del by del T minus del L by del Q is equal to 0. If the Lagrangian is the function of Q dot and T, then equation of motion will be this. Here Q is the position coordinate, Q dot is the velocity coordinate, and T is the time. Okay. And what is generalized coordinate? That is, generalized coordinate is the coordinate for which we are expressing the equation of motion. As you can see here, the generalized coordinates are theta, phi, and x and y. Theta, phi, x and y, that is the minimum independent coordinate required to describe the equation of motion. Okay, but here do you know the what is cyclic coordinate? Cyclic coordinate is the coordinate for which the linear momentum is conserved. Okay, that means there will be no q in Lagrangian, so that del L by del Q will be 0. That implies del by del T of del L by del Q dot is equal to 0, and here del L by del Q dot is equal to PQ is the conjugate moment. That implies del PQ by del T is equal to 0. That implies PQ is equal to conserved. Okay, for that Q is the cyclic one. Here we have to check from the equation of motion of Lagrangian that which are the cyclic coordinate and what is the equation of motion. Okay. For for x, if we take x, then our equation of motion will be del L by del x dot del by del t minus del L by del x is equal to 0. See, in the Lagrangian there is no x term, so del L by del x is equal to 0. That implies here del by del t of, if I take it as px is equal to 0. That implies px is equal to constant of motion, that is conserved. Okay. So x is our cyclic coordinate. And then for y, the equation of motion is like x is y dot minus del L by del y is equal to 0. See the Lagrangian. See, there is no y term. Okay. So our del L by del y is equal to 0. That implies Py is equal to conserved. Okay. So y is also cyclic coordinate. Similarly, if you see that phi, there is no phi term. Phi dot is there, but phi is not there. So our phi is also cyclic. We have first considered that theta, phi and x, y are generalized coordinates, but no, these are not generalized coordinates because x is cyclic coordinate, y is also cyclic coordinate, phi is also cyclic coordinate. Remaining and one remain, that is theta. We have to check is it for generalized coordinate or coordinate. Obviously that is generalized coordinate, but that is not cyclic because there is no because there is theta term. So the equation of motion for the theta will be, for theta del L by del theta dot del by del t minus del L by del theta will be 0. If you do the simplification, you will get that the equation of motion will be, I am not doing because it will be little bit lengthy, not lengthy, but you can find by your own. I have already find it, so I am writing directly my square theta double dot minus p x double dot sin theta plus by double dot cos theta plus half m capital M r square and theta double dot is equal to 0. This is the equation of motion for the theta. Okay. And let us see the conclusion. We get that the equation of motion and are the constants we find. As you can see, there is potential 0 and energy, and the Lagrangian is independent of time coordinates, so energy is also constant, and the linear momentum are constant. As potential is 0, so force is negative guard of position, so the force is also 0. So here the external force is 0, and that is the thing. So kinetic energy is also conserved, you can say. Okay, and this is all the things I have explained. You can I hope you all understand that. So thank you. Keep watching and please subscribe and share. Thank you.